So we're going to go through the work for exercise 9e of the Pearson Applied 1 textbook. So this is about motion under gravity. So we're using Suvat equations on particles which are moving freely under gravity. So first of all, we'll have a quick look at what gravity is. I'm sure most of you are familiar with it. So it causes objects to fall to Earth or any other planet. If you're on a different planet, basically it just makes things move towards masses. The acceleration caused by gravity is considered to be constant. Obviously it does actually vary, but we're going to treat it as being constant. We're going to ignore air resistance at this stage. So the acceleration will be the same regardless of the size of the object, and the acceleration caused by gravity will also be the same. We'll treat it as 9.8 meters per second squared to two significant figures. We need to be careful when we're doing these calculations. Remember, gravity is always going downwards, so when you decide which direction you're taking is positive for the motion, you need to consider whether gravity is going to be positive 9.8 or negative 9.8. And finally, the time of flight is the time from when a particle is released to when it lands, when it stops moving. Okay, so let's go through a couple of examples. So here are our Suvat equations, all 5 of them that we know. So a ball is projected vertically upwards from point O with speed 12 meters per second. We need to find the greatest height reached by the ball and the total time it's in the air. Okay, so as with all of these questions, we're going to begin with a diagram. So we draw a diagram, and the ball is projected vertically with a speed of 12 meters per second. When it gets to its greatest height, obviously its speed is going to be 0. Okay, so if we're trying to find the greatest height reached by the ball, we can use a Suvat equation. So S is the thing we're looking for. It's the distance it's travelled to get from its projection point to its height. U is the initial velocity, which is 12. We can say V is going to be 0 because the velocity is 0 when it reaches the maximum height. And now because we're taking upwards as positive, we remember that the acceleration is going to be negative 9.8. And the time we don't know. Okay, so we're trying to find S. We've got U, V and A, so we can use V squared equals U squared plus 2AS. Sub in the values we've got and solve them, and we'll get the greatest height reached by the ball is 7.4 meters. And we need to keep that to two significant figures because we've used gravity in there, which has been rounded to two significant figures. It would be inappropriate to give our answer to a higher degree of accuracy. Okay, now we need to find the total time. So we know the total time it's in the air. So if we're talking about from when it's projected to when it hits the ground again, the displacement is going to be 0, okay, because it's come back to where it was. U is 12, we know that. V, at the moment, we're not going to use, although by symmetry of the motion of these particles, we could work out it's going to be minus 12, but we're not going to use that. A is minus 9.8, again, because we're taking upwards as a positive, and we're trying to find the time. Now, because what we're feeding into this Suvat equation is just that the displacement is 0, we should expect to get two solutions. One of them will be 0 because that's where it's starting from, and the other one is the value we're after. So we're trying to find t. We've got s, u and a, so we're going to use s equals ut plus half at squared. And we're going to sub in the values we've got and simplify it, factorise it. So obviously we get t is 0 is one solution and 2.4 is the other one. So obviously we're going to use 2.4 seconds to two significant figures. Okay. So now if we look at another example, so a book falls off of the top shelf of a bookcase. The shelf is 1.4 meters above the ground. We need to find the time it takes to reach the floor and the speed with which it hits the floor. Okay, so obviously we're looking at this question, we're picking out the key bits of information. So we don't care that it's a book, we're going to draw it as a particle anyway. It falls off the top shelf, it's not projected, so the initial velocity will be 0. Now we don't care if it's the top shelf or it's a bookcase. And it's 1.4 meters high. We're going to use that. So we're going to start by drawing a diagram. So there's our bookcase, 1.4 meters high. Our book is a particle, and we know it's going to start with speed 0, and then it's going to hit the ground. So we know that the distance it's going to travel is 1.4, so we have taking downwards as positive here. U is 0. V we're not finding at the moment, we don't know it. A, we've taken downwards as positive, so A is 9.8, and T is what we're trying to find. So we're trying to find T, we've got S, U and A, so S equals UT plus half AT squared. Sub in the values we've got, and solve it. Now we get two solutions here effectively. When we take the square root, we would get positive and negative. Obviously we're going to take the positive one because we're not travelling backwards in time. Theoretically, if this continued its journey backwards, it would be at 0 again at the negative value. But we're going to take the positive one, so t is 0.53 seconds, the two significant figures. Right, now we're trying to find the speed with which it hits the floor. So we're trying to find v, we've got s, u and a, so v squared equals u squared plus 2as. Subbing our values, and again we're going to find two solutions, but we'll take the positive one. Next example we go through, a ball is projected vertically upwards from point X, which is 7 meters above the ground, with initial speed of 21 meters per second. We're going to find the time of flight of the ball. So remember, the time of flight is from when it's projected to when it hits the ground. So we'll draw a diagram to start us off. We know it's projected from 7 meters above the ground at 21 meters per second. Okay, and we're trying to find the time from when it is projected to when it hits the ground. So we know that the displacement is going to be -7. If we take upwards as positive, from where it starts to where it lands, its displacement is -7. U is 21 as we're given in the question. We're not concerned with V. A is going to be -9.8 because obviously we're taking upwards as positive. And T is what we're trying to find. So if we're trying to find T, we've got S, U and A. So we're going to use S equals UT plus half AT squared. Sub in our values and solve it. Again, we're going to get two solutions. One will be positive, one will be negative. Obviously the one we're after is the positive one. So solve it using the quadratic formula. You get 4.6 or minus 0.3, so we'll take the positive one to two significant figures, and that's the time of flight of the ball. Right, next example we're going to look at. A particle is projected vertically upwards from point O with initial speed u, and it reaches a greatest height of 62.5 meters above the ground. So we need to find the speed of projection, u, and we also want to find the total time for which it's 50 meters above or more above the ground. So we're going to start by drawing a diagram. So it's projected from the ground with speed u, goes up, comes back down again, and the greatest height it reaches is 62.5. So to work out u, we're going to look at the journey from the ground to its maximum point. So s is going to be 62.5. U is what we're trying to find. When it reaches the maximum point, it has 0 velocity, so v is 0. We've taken upwards as positive, so a is going to be -9.8. And t isn't something we're concerned with. So we're trying to find u. We've got s, v and a. So we're using v squared equals u squared plus 2as. Sub in the values we've got, and then again we'll get our solution. We're going to take our positive one of 35 meters per second, and then next part we're trying to find the total time for which it's 50 meters or more above the ground. So the way we do this, we can work out the times at which it is exactly 50 meters above the ground. So there'll be two. There'll be one on the way up and one on the way down, and the duration for which it's above 50 meters. Is just the difference between those. So we're trying to find the times at which it's 50 meters above the ground. So we know that S is going to be 50. U is what we've just worked out, is 35 meters per second. V we're not concerned about. A is -9.8 because we're taking upwards as positive. And T is the thing we're trying to find. And we're expecting to find two solutions here. So we're trying to find T. We've got S, U and A. So we can use S equals UT plus half AT squared, sub in our values and solve it. Okay, so solving it using the formula, and get those two values. So on the way up it's 1.9742, on the way down it's 5.1686. So to find the time in between those, we just subtract the smallest from the largest, give our answer to two significant figures, so it's 3.2 seconds. Quite a common type of question to get in exams. Right, next one, a slightly more complicated one. So we've got two particles this time. So a ball A falls vertically from rest at the top of a tower which is 63 meters high. At the same time, that's important, at the same time as A begins to fall, another ball B is projected vertically upwards from the bottom of the tower with velocity 21 meters per second. and they collide. So we're trying to find the height at which they collide. Okay, so obviously we're going to start off by drawing a diagram. So we've got a 63 metre tower, and we've got a particle at the top, a particle at the bottom. So we know that they're going to collide somewhere in the middle. So we're going to have two displacements to consider, one for the first particle and one for the second particle. Okay, so we know that particle B is projected vertically with a speed of 21. Particle A goes from rest. So we need to consider them both. We're going to call the two displacements S1 and S2. So we're going to do a Suvat equation for each to find an expression for the displacement. Okay, so be careful about the acceleration as well. So particle A, we know the displacement is S1. We know the initial velocity is 0 because it's from rest. V we're not concerned about. A is positive 9.8 because we're taking downwards as positive. And T is just the time from when they're projected to when they collide. Okay, so we can call that T. For particle B, the displacement is S2. And this time we're taking upwards as positive. We know U is 21, V we're not concerned about. And because we took upwards as positive, A is minus 9.8 and T is T as well. So for both of these, the values we're concerned with are S, U, A and T. So we can use S equals UT plus half AT squared for both. Sub in our values and simplify it. So for the first one we get that expression, and for the second, very similarly, we get that quadratic. Okay, so obviously we're trying to find S2 because that's the height, which is what we're after. So we have some information connecting S1 and S2. We know that they're going to add up to 63 meters. So if we add our two equations together, the t squared component cancels out. We know that S1 plus S2 is 63, so we can calculate that t is going to be 3 seconds. So we know from when they're projected to when they collide is 3 seconds. Now we can use that and sub that back into our expression for ball B. Okay, so we know t is 3, so sub that in, and we get S is 18.9 meters, or 19 meters to two significant figures. So they're common types of questions. The ones with two particles are probably the most challenging ones. So make sure you get plenty of practice on these. So have a go at exercise 9E now.